Okay, students, this lesson is Congruence in Transformations in ALEX. All right, this time I'm shooting my Chromebook screen because I think it's might be a little easier with some of these lessons. All right, the first question, which pairs of the figures below are congruent? Okay, looking at number one, congruent means they are clones of each other, same size, same shape, everything the same. Okay, those two are not, so that's a no. Okay, these two are not, so that's a no. Do you see how easy these two questions are going to go? I think there's two. Now, do you see this shape? That's 3 across and 4 tall. That's 3 across and 4 tall. Those are the same, they're just turned. So that's a yes. This one, I'll go ahead and, well, I don't want to have to answer every question because I already know. I mean, I'm going to go through it and say yes or no, but I'm not going to show you me clicking it, okay? All right, the next one, no. All right, done with number one. Congruence, the same, exactly the same, everything the same. Look at this, no. Look at this, 3 and then 4 across, 3 and then 4 down. Yes, that's congruent, they are the same. Okay, easily tell no. Easily say yes. I hope you get that. If you don't, just watch this again. Remember, congruent means they have to be, if I see this shape, I have to see this exact shape here, and I don't. This is just turned on its side. This is just flipped, okay? This is not the same size, okay? All right, so number 3. See how fast it goes? See how the videos help you? The kids that are being very stubborn and not watching the videos end up emailing me, asking me individual questions. I don't mind that to a point, but it's kind of like, I want you to watch the videos. All right, here we go. So which of these, for each pair of the figures, choose how they're related. Okay, so we're either gonna turn them, we're gonna slide them, or we're gonna flip them. We're gonna translate them, slide, reflect, flip, rotation, turn, or none of these. There's never going to be a none of these from what I can see. All right, that's a turn. So that's called a rotation. See how it rotated? This, you flipped it. That's called a reflection. This, you were sliding up and over or to the right and up. That is because they're still facing the same direction and everything. That's called a translation. So this is a turn, rotation. This is a flip, reflection. This is a translation, which is a slide. So what's this one? I hope you know it. What is it? Rotation. Okay? There's only 2 questions like this as well. Okay. See, I get to deal with the same things you do, all buffering and all. All right, see this? Still pointing up, still pointing up. That was a translation. That didn't, it just, you're sliding it. This one, they're facing the opposite ways of each other because they were reflected, reflection. This, anytime you see it where it's touching at a point, that's a rotation, it's turning. It keeps turning, okay? Turning, or turning. This is clockwise, that's counter, we don't know which, but we know it's turning, rotation. This one, what is it? Yeah, you're right, reflection. Okay. On to the different type of question, and this is the main reason why I wanted to do this, is to show you how to work this part. In each part, translate, move, or slide the solid figure exactly onto the dashed figure. If it's not possible, click on not possible. Okay, see my hand? Woo, there's my hand going along with my little cursor. So I have to take this shape, see how it turns yellow? If you can see my fingers, well, all I'm doing is tapping. Look, when I tapped, his hand grabbed it. When I tapped again, it's pointing to it. Tap it again. I just have to get it near the shape in order to grab it. It just grabbed my shape. Now, I'm not even clicking hard. I'm just moving, I'm slightly moving my finger like this, okay? Very slight. And all I have to do is just see, can I slide this figure, see the way it's pointed, like leaning to the right? And then I need to drop it. If it drops and there's no overlap whatsoever, do you see that? No overlap whatsoever? then I have done good. And that means that you can translate this from here to here. Now watch how I would have done it. I would have counted up on boxes, up, 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 and now to the right, 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 bam. Or what other way could I have done it? I went up and to the right. Is there another way to have done it without going diagonal? Because remember, on a grid, you can either slide up and to the right, down and to the right, or up and to the left, or down and to the left. So what other, if I showed you the going up and right, which other way can you do? Well, you can go right first and then up, bam, okay? I promise I won't say bam anymore. That sounds stupid, doesn't it? Yes, it does. All right, grab my shape and I'm gonna see, wait, can anybody figure this out without trying to do it? Okay, so sure, I'll grab it and gee, when I let it down, something happens. It doesn't cover it all. It's not covering the dotted lines anymore. There's overlap. There's stuff sticking out. So you know what that means? Huh? What does it mean? Not possible. So click on not possible. And now that's your answer. Okay? Now let's move on to number 6, which is also a translation. Okay? So again, this is not pushing down hard on my pad. I'm just tapping it and I just grabbed it. And I don't know about you, but without needing to, I can grab it and slide it over. I can tell it's translation, duh. Okay, can I grab this and slide it up? No, because you know why? This is not a translation, okay? You know what this is? It's called a reflection. So, what am I going to put? It's not a translation, which is what they asked. And they said, translate. Well, I can't translate. I can reflect it, but I can't translate. So I'm pushing not possible. Number 7, we're halfway done. And I've been going really slow. All right, number 7. This time now we're reflecting. Okay, so this is how it works with the reflections. See this up here? There's the reflection over, they're showing you a reflection over the x-axis, and they're showing you a reflection over the y-axis. Here's the x-axis, here's the y-axis. Now, some of you that don't think you need any teaching whatsoever, you think that this is not a reflection because this is only two boxes away from the axis, the y-axis, and this is lots more. Okay, well, smarty pants, first off, we're not going to go over the x-axis because the shape isn't up here. So it has to be over the y-axis, so I'm just going to match it to this one. Now watch. I can move my reflection line. See that? It doesn't have to be on the y-axis, all you smarty pants people. You kill me. Okay, all I have to do is I can say, well, where would it be in the middle? Well, I have to count my boxes. Watch what I'm doing. I'm moving my reflection line. I'm counting boxes. 1, 2, 3, 4, 5, 6. So if I go halfway between 6, which is 3 boxes, 1, 2, 3, and I tap it, then it shows that this jumped over right over here. Now, what if I didn't? What if I said, I don't know if I can undo it. Wait a second. Yes, I can. Okay. So let me try this again. What if I say it's on the axis? I'm going to put my line of reflection on my axis. So it shows when you would flip this, because this is the original. When you flip it, it's not over the dotted line. It's not covering up the dotted line. I overshot it. You know why? Because I wasn't supposed to just drop it there. I'm supposed to move my reflection line as needed. And now the blue shape is right over the dotted line. Now do you know how to do it? Good. All right. When you see this is not congruent, remember on the last questions we said, hey, congruent or not congruent? Not congruent, you don't have to worry about trying to reflect it. I'll try it, and this, by the way, is over the x-axis. But how many boxes are between them? Well, it's perfectly between the two. 3 boxes to the actual reflection line, and then there's 3 above. So I should just be able to drop it there. But look, when this flipped down, oh, wait a minute, it's too small. It's not the same size. Exactly. So we don't say that that's, hey, I did it. You have to cover up the entire dotted line with the blue line. So, but I knew this was only 2 boxes tall, and this was 3 boxes tall. So I already knew it was not possible. I was just trying to show you and prove to you that sometimes you got to really look at the shape. All right, number 8. Okay, and we only got 14, so woohoo. All right, here we go. In each part, reflect. It's another reflection. Okay, which axis are you jumping over? X. So this is the x-axis, the horizontal line. Okay, this is the y-axis. This is reflection over the y-axis. We're going to take the x-axis. Remember, I get to place my line. All right, my reflection line. 1, 2, 3, 4, 5, 6. But I noticed something. See how this R looks like a mirror image, and this R looks like facing 2 directions, and this one's up and this one's down? What do you think about these shapes? Do you think that this looks more like a translation than a reflection? Let's see. All right, how many boxes did I say? 1, 2, actually it's between these 2. 1, 2, 3, 4. So should be 2 boxes. So the 2 lines here. I kind of misspoke a minute ago. So that's in the middle. All right, let's drop it. Oh, bummer. See, that doesn't work. It was a translation. A lot of you knew that. And you're going, see, you waste my time, Miss Martin. I don't care. I'm proving to you. That's what happens if you don't reflect it. Okay. I mean, if it says a translation, or if it's translating and it's supposed to be a reflection, it's not possible. All right, I think we're moving on to what? Make sure, oh, I forgot to do the second one. Okay, sure thing. Okay, so here, what does that look like? Hopefully you're saying, that looks good, that is a reflection. And the easy thing is, and first off, this is the line of reflection, which means the y-axis, so I'm gonna grab this one. Now, and I'm just tapping it. Again, I'm just tapping it, and I'm very slightly, I'll tell you if I have to push down and push hard and drag. I hate that, but we don't have to on any of these. That's what's nice. This one is already off of the y-axis, so I can just drop it, and you can see nothing is poking out, nothing is overlapping. This was a good reflection right off of the y-axis. Okay. Alrighty, moving on to number 9. And I think this is rotations now, if I'm not mistaken. As soon as it keeps buffering. So, wait. So for rotation, remember there's clockwise and there's counterclockwise, okay? So you just gotta keep that in mind when we're working these problems, okay? Unlike you, I did just scroll down to make sure that I did answer that question. Unlike you, I'm not gonna sit here and click and click and click and click. Perhaps it's hung up, but I'm gonna let it breathe. I'm gonna let it try to fix itself. Because I'm looking at my Wi-Fi and it looks like I got some Wi-Fi. All right, now I'm gonna go ahead and because this is a teacher's view, I'm previewing the assignment that I made. So I'm gonna go ahead and click on to number 9 and see, no, it's hanging, it's just hung. Well, now I'm being you, which is bad. I'm just making it mad. I am going to come down here and check my, well, it does say it's weak. Dang it. All right. I'm re-clicking, turning the Wi-Fi on, connecting. All right. It's connected. Okay. Yeah, okay. Now this is when I wish I had you with me. If worse comes to worse, I'm gonna move on. I can do this all on the rest of it on paper because I do have it on paper. So, you know, I will. I'm not gonna waste any more time. It was fun while it lasted for whatever reason. I wanted to be nasty. Okay, so on number 9, on mine, when we rotate it, and I'll show you what it looks like on my key. And there's just no way to, because I am previewing it, there's nothing at the top that I can refresh. Oh boy, and you guys are saying, don't you know how to, oh, I know. I can do the refresh button up here. Yay! Took me a second. All right, whatever. Start. And we were on number 9. Here we go. All right, number 9. Yay! Let's see if it works. Okay. There we go. All right, now we're rotating. Hallelujah. Okay, and do you see this? See, there's the original. See my little hand? Do you see this little dash right here? Bam! That's where we're gonna be rotating from. We're gonna look at that to help me know how many turns there are. So I'm just gonna practice this. I'm gonna grab it. Remember, all you gotta do is tap. It's grabbed. So look what I do. If I go, look at the little blue line here, starting at the origin, rotating about the origin, I just go to there. Where did I go? I went from that point to up here. So this part of the x-axis, now I'm on this part of the y-axis, and that's a rotation. How many degrees? It only went 1 quadrant over, so it's 90 degrees rotation, but is it going clockwise or counterclockwise? So I'm going this direction, and the arrow reminds you, if you're going left, that's backwards on a clock. That's scary time when you see backwards clocks, okay? Like Stranger Things. I don't know if it was on Stranger Things, but anyway, that's counterclockwise. Now, if I go the other way, watch what happens. When I go the other way, look, now the arrow is going this way, like clockwise. And that would be the next rotation down clockwise. Now, looking at that, I can't get to it that way because that didn't, see, that's not covering that up. So just to make sure, not that one, that's a 90 degree. That's called 90 plus 90 is 180 degrees. And then just one more turn would be 270 degrees. So I thought, just for grins, I went backwards to see. But I kind of knew already. I'll tell you what, when you look at this and you see, it looks like to me, they just translated it down. You're right, woo! Not possible. All right, that was a lot of fun. I enjoyed that. Number 10. Okay, here we go. Well, I thought number 10. Okay, there we go. Number 10. Texas is coming out in me. All right. Let's see, because it looks, first off, the shape is the same. Ooh, is it? I don't know. Is it? Let me just check. That's too, the little shorter side's too tall. Okay, maybe it is. For just 1 minute, I thought they were trying to trick me, but maybe not. All right, so let's see. You know what? Even if you originally think, hey, I don't know if that works, check it, because, you know, you might sometimes just make a silly mistake. We know how that happens. All right, so I'm grabbing, oh, that's, I went to the dotted, I do that a lot. I'll go to the finished figure, the final figure, and I forget, and actually I'm supposed to come here. Okay, I'm gonna grab it, there, okay, I grabbed it. Did you hear me tapping? That's all I had to do. So I'm gonna see, that's 90 degrees, which direction? Clockwise or counter? Clockwise. That's 180 degrees, clockwise, 180 degrees. The next one is another 90 added on to 180, or 90 times 3 is 270. And each time I just hit this line, and see the little blue line? I hit this part of the axis and bam, it fits on there. So I'm gonna drop it and it works. So see, I started here, down here. 1 turn, 2 turns, 3 turns. Counterclockwise. You got me there. Okay? All right, so that is possible. And, you know, just for grins, let's just see something. Would it have worked if I was here? Would it have worked if I'd gone counterclockwise 90 degrees? What do you think? Some of you already know. So I'm gonna go. Counter means backwards. So I'm gonna take this line and I'm gonna take it up to there. All right, so let's see. Look, it does work. So I could have gone 1 turn going counterclockwise, or I could have gone 1 from here, 1, 2, 3 turns clockwise. Either way, going forwards or backwards, it does still land on the, shape, just so you know. All right, number 11. Oh, I forgot to do the second one. That's nice that it reminds me. Okay, down here, let's go. Pick it up. I did it right this time. So I'm picking up the shape, and there's my little line to help me guide to get to the next part of the axis. So that's 1 turn. Which direction? Clockwise. And I remember, I can go this way or I can go this way. Some of you are saying, why don't you go backwards? I don't know. I like clockwise better. Doesn't mean that it works every time, but hey, I'm doing it. 1, 2, and what am I gauging? I'm not looking at this at all. I'm looking at this line. See how it's flat? That's how I'm gauging. 2 turns. Almost. Oh, you know what I was doing? Hold on. 3 turns and drop it. Gee, is that in the same spot? See, I'm straight up. Is that in the same spot? Nope. So you know what you say? Not possible. Is this clicking? I hope it is. Number 11. Oh man, don't do that. Okay, let's see. Okay, yay! All right, now this one, oh my gosh, look at all that. Trust me, this is not hard. It really isn't, okay? First off, I haven't seen oh yeah, that's true. I have seen a none of these. There's one time that you'll see a none of these, and it happens to be one of these questions right here. Can you figure out which one of these? Answer the question below. Are figure A and B congruent? Are figure C and D congruent? Okay, so if it's not congruent, then you can't translate, reflect it, or rotate it to make it match exactly onto the other shape, okay? So let's just see. Taking a look at this, do you see those? Do those look like they're the same size? Well, they're not. So that's not congruent. So you know what that means? If it's not congruent, don't worry. It won't, none of these will map. And M-A-P, the word map, we've talked about this before, the word map, but mapping means that you can grab it and translate it or reflect it or rotate it right on top of the final figure. And no, you can't. So you know what you say? None of these. That's the only time it works. That's the only time you click on that. Is if you get a no on the congruency, then you click none of these. Got it? Okay, so here we go. This shape's exactly the same. So that's a yes on the congruent. And then which transformation will map figure C onto figure D directly? Now you can't grab it. Unfortunately, there's nothing that you can grab. They want to know, how do you get from C to D? Well, do you translate figure C to the right 7 units, picking up figure C and moving to the right? That did, look, my arrow's not even in the right quadrant. Okay, what about up? Well, no. It's saying translate 7 up. No. So how about reflect the C over the x-axis? Well, if I reflect it down, then this point up here is going to be pointing down. Right now, the point's going to the right, so that doesn't work. Reflect figure C over the y-axis. Well, no, because it ends up reflecting over there. So let me, okay. So the next one, I have to kind of scroll down. Rotate figure C clockwise 90 degrees about the origin, meaning with that little line down there that we saw. So if we use that little line and we are going to take this and we take that little line and we go down to this line right here, that would be going 90 degrees. Then that's my shape would be in this quadrant, which is what I need, okay? Because the other possibility is to go counterclockwise 180 about the origin. Well, first off, here's what I teach. You're one away. That's one turn away. And if you know the direction and it says clockwise, if I can go clockwise one turn, it works. Okay? If it says 180, no matter what, you're always going to end up in the down in the diagonal from that shape, because 1, 2 gets 2 turns gets me there. That's 180. If I'm here and I go backwards, 1, 2, I still get here. So that makes sense. So if it's 180, but you're right next door, like you're either here or you're here, that's going to be one of your answers. Never 180 from this one, because the final figure is just one away. Now it could possibly be 3 turns away. They could say 270, all right? But again, right now I'm just gonna say, hey, I know this one, if I go one turn to the right, it's gonna be, it's gonna work with that rotation. So I'm gonna click that, and that's the right answer, okay? All right, number 12. Number 12, okay. Isn't this fun? All righty, number 12, are they congruent? Yes. Okay, that means that I have to pick one of these. One of these is gonna be the answer, okay? Okay, so, all right. Oh, these are different than, that's right, from what I printed. It doesn't matter. That's okay. Okay, so, because I like to have my key just to make sure I'm not being silly. All right, figure A to get to figure B. Okay, so translate A to the right 5. No. Translate figure A up 5. No. Reflect A over the x-axis. No, because you end up here. Reflect it over the y-axis. No, because if I do, this point has to be pointing up, and it's not. It's pointing to the side. Rotate 90 degrees clockwise. So if I'm going to go take this shape, if I just take that point, and I'm going to go 90 degrees clockwise, that point is going to be facing, this is going to face to the right, and that's it. This is it. 180, remember 180 would mean it'd be where? Up here. So that's not going to happen. So it is this answer. Rotate 90 degrees clockwise, because it's one turn and I'm going clockwise, and it's the only one that says 90 degrees anyway, so that helps us eliminate the bad answers. Okay, are these congruent? Yes. So it's going to be one of these. So here we go. Now this is it looks like to me a reflection. So if it's 2 boxes to the left away from the y-axis and 2 boxes to the right, that is a reflection over the y-axis. So I'm going to look, now that I think I know what the answer is, translate figure C, there's C, to the left 3 units. Nope. Down 3 units. Nope. Reflect over the x-axis. Well, that's the x-axis there. Nope. Reflected over the y-axis. Ooh, that looks good. Rotate it 180 degrees. Well, 1, 2. Remember, I just go down diagonally. Nope. Counterclockwise. Okay, counterclockwise is going backwards. 90 degrees. Nope, I end up down. So guess what? It is a reflection over the y-axis. Now, some of you are already going to know it, and you'll just pick it. And cool, that's okay. All right, number 13. We got 2 more on this. Okay. Here we go. Now, this is there's 2 more questions, and this one has 2 directions to do. This down here would be like me saying, okay, you're going to go 3 steps forward, and then you're going to take 2 steps right. Or you're going to go 5 steps down, and then you're going to go 3 steps to your left. So it's 2 directions, all right? This is a translate, then reflect, reflect, then translate. And I want you to notice something. Do you see this? Translate figure A down 9. Now go to the next one. Translate down 9. And then this says, then reflect over the y-axis. And this says, reflect over the y-axis. These are the exact same directions. They just said to do translate first and then reflect. Instead of, in this one they said reflect and then translate. That's no different than me saying, hey, I'm gonna have you go one step up and one step right. And then the next time around, I'm gonna go now from the same spot, go back to your original spot. Now I'm gonna ask you to go one right and one up. I gave you the exact same directions, but I flipped them in which order I gave them, and you still ended up in the same spot, okay? If you didn't hear that, go back, watch it again, watch this part of the video again. So there could be more than one answer here, just saying. All right, here we go. Here's my shape. I can already tell you, I don't know about you, but hopefully you realize every time your shape turns on its side, either right or left, that's a rotation involved, okay? And so I can tell you right now, that would, if I wanted to go left, and actually, I can't go left and left again because this is gonna turn on its side here, and then it's gonna point down here, like a reflection, like flipping it. So I know it's not 180 degree rotation for the movement at the moment. So here we go. We're gonna look at this. This says translate figure 8A. Here's A. 9 down. All right. And then reflect that over the y-axis. Well, right now, if I just translate this down, it's pointing up. If I reflect it over here, it still has to point up. So it's not the first answer. Reflect figure A over the y-axis, okay, flip it over, and then translate that down 9 units. Remember what I said? These are the exact same directions. So if it didn't work for the first one, it's not gonna work for the second one. It says the same thing, just a different order. Now, the third one, I'm gonna have to toggle up and down here. Reflect figure A over the y-axis, then rotate that clockwise 180. So reflect figure A over the y-axis, okay, reflect over here. Now, if I go to 180, that ends up over here. So this one, the third one was not the answer, reflecting and then rotating 180. And then they have rotate figure A counterclockwise 90 degrees about the origin, okay? So rotate this 90 degrees counterclockwise, okay? So when I turn it, it's gonna turn on its side and point this direction, okay? Like this shape. It's gonna look like this, that direction. Now, it says, then translate that down 7 units. Okay, so I'm just gonna tell you right now, like if we were to do this, okay, and we were to turn this over, and if we go down 7 units, it's gonna work. You don't have to count the boxes. If you're just in the same quadrant, you've got the right answer, okay? So, meaning if you end up in this quadrant, if I turn it and then I translate down and end up in this quadrant, then that's the answer. It's not that picky. Okay, so that's my answer. Okay, one more, and then we're done with this lesson. And a lot of teaching happened in this lesson, by the way. Okay, because now we're really picking up shapes and we're translating and reflecting them. And am I on 14? That doesn't look, no, I'm not on 14. Rotating. Okay, I'm getting you used to seeing, well, Alex is getting you used to seeing, oh, I can tell. Like this one right now, because it looks like it fell on its side, it was rotated. So I know there's a rotation, okay? So let's just see our answers. Are they congruent? Yes, these shapes are the same, so that's congruent. So now I'm gonna look here. Okay, translate figure A, there's A. 10 to the left, all right, just translate it. And then reflect it over the x-axis. To reflect it, the point that's to the right, will, even when I move it, the point will still be to the right. So it's not the first one. Second one, reflect A over the y-axis, okay, so over the y-axis would be reflecting it over here. Okay, so when I reflect it, that point ends up facing this direction, the left. And then rotate that result 90 degrees clockwise. If I'm gonna end up here and it tells me to go clockwise, and I know when I rotate, if it's on its side, it's gonna rotate up, then I know that this is gonna be my answer. But just to prove it, I'm gonna show you. Reflect over the y-axis and then translate 9 up, okay? So if I reflect it, it's on its side. So when I translate it up, that point, this shape is still on its side. So nope, that didn't work. And then rotate the figure 180 degrees clockwise, then reflect over X. Okay, so if I take this and I go 180 degrees, that's 2 turns, I'm gonna end up here. And then it says to reflect over X. Nope. So no answer but the second one. Reflect over the y-axis, reflect, and then rotate 90 degrees clockwise, ends up here. So this is my answer. Okay, those are the 2 hardest problems because you got more than one direction that they've told you to go. But I'm going to tell you, with all the other practice, with all of these through here, that should have helped you navigate a little bit easier. Like this, that's definitely a rotation, guys. You just have to remember, when it looks like it turned on its side, it's been rotated. Okay? Okay, so that's it. We have finished this lesson. And the dogs are gonna bark. I love it. All right.